This is Aaron Murakami with eMediaPress.com and the Energy, Science, and Technology Conference. And on July 7th through the 11th is a 5-day conference with about 19 presenters and about 21 presentations at the Kootenai County Fairgrounds in Coeur d'Alene, Idaho. That's about an hour from the Spokane International Airport, and you can go to EnergyScienceConference.com for more details. And for the other books and videos, you can go to eMediaPress.com. Also, we have Eric Dollard here. His website is ericpdollard.com, and you can learn more about his work. The organization that we have that's dedicated to furthering the work of Eric in the electrical sciences is ericpdollard.com. There are some free papers on there. You can look at some free videos. There's also a list of all the different presentations he's done. And also in the right column, you can donate by PayPal or through the mail to help support the nonprofit. It is a 501c3, and all donations are tax deductible. Eric's been up here for the last 3.5, almost 4 months or so, and we've been working on this project, which is not complete, but we got pretty much all the metalwork and machining done on another part of the journey here. We're going to be doing all the wiring and testing, and we'll at least probably bring these units to the conference so people can look at them. If you look at the other pictures and videos, you'll see 2 racks, an audio rack, an RF rack, and a Tesla coil setup, and they can be used individually or together. And do you want to go through what each panel is and kind of what the purpose is? And this is not all of them. This is just 2 out of 6 or 7 units on the RF rack. But what are we looking at here?
Well, this is the most important part. This replaces the Collins transmitter, which was on the wrong frequency. So we had to build a complete new transmitter on that frequency. So it physically, not wiring-wise or component-wise, but physically, it was just completed today. So this is what it looks like. And then this is one of the power supplies for the vacuum tubes that are the power amplifier that this runs.
So this tuning unit, so originally the Collins, we were planning on using that for the Tesla coil setup, and there's a gap from about 4 to 6 something megacycles, and luckily we had a tuning unit that happens to be in this right now. And let's see if we can show what it kind of looks like.
That's out of a World War II B-17 aircraft, and this was the plug-in tuning unit for a 100-watt transmitter called the BC-375. So having the tuning unit, the BC-375 has been compacted into a smaller, more versatile package and setup, which basically kind of replicates the Collins 32V transmitter.
And we had 4 of these on 4 different
bands, yeah.
And so luckily we had one that was specific to the missing gap on the Collins. And so you can look at this plate, this dial. It's essentially Jeff replicated this on a brand new panel with the rest of the unit. So see, I'll do a little close up in here. So this was all literally made from scratch, blank panels, and Eric did the engineering. I did a lot of metal work. Jeff did pretty much all the machining, and massive effort. This is the most complicated unit. That's going to be the heaviest, and it's pretty intense, the work that went into this. This is just to show kind of what the tubes look like. Some of the transformers and
yeah, so you can see
the relays down here.
You can kind of see inside the tuning unit with the covers off.
Yeah,
so that's this is the tuning unit.
There's the capacitor, and
then this is the oscillator amplifier that replaces the setup in the BC-375 transmitter. So this is much more compacted. The modulator for this, though, is external. So this is basically lacking the modulator that's in the BC-375. And then the various rectifiers and voltage regulator tubes. It's important to keep the frequency really accurate and not have a lot of drifting in voltage and what have you. So that's what a lot of these tubes are for, is they're regulators. And this is the power amplifier. This is what steps it up to 120 watts. This is the oscillator tube. So all the terminals in here is where all the resistors and capacitors will go.
Like I mentioned, all the wiring and testing, all that's going to have to be on another episode. And then
so this is basically a power supply, at least the rectifier part of it, and also the metering and the control for all the voltages it puts out.
Can walk over to the radio rack.
Yeah.
So this is the Collins with the missing gap. We've covered that in a different video that tuning unit fills.
Not tuning unit, transmitter.
Or I mean a transmitter.
So basically that transmitter in there is kind of duplicating this transmitter for one specific band that's missing.
Yeah, you can see it ends at 4 megacycle here and picks up at 6.4. And this is only part of the Tesla coil setup, but it's in that missing band, so we had to make another one of these. And this is the RF rack. We've already went over this bottom part here. This is the power amplifier. This will have what kind of iMac tubes?
4-250s.
So I just kind of got the frame assembled today. So it's been a massive effort and it's not over yet. This is just some of the parts here that we haven't walked through the parts in a while, but this is all these are the potential coils that go on that Tesla coil setup over there. One on either assembly on either side of the current coils. So these are just all parts, resistors, meters, other parts that'll be used to kind of finish everything off. This is a unit scavenged some parts out of. Can't tell you how much hardware we went. These bins are full, but they've been full more than once. All of these, I never want to drill another hole for the rest of my life. This is where Eric sits and does the calculations and layout. This is
yeah, that's the makeup of the audio and the RF rack. So this is the audio rack. So that's what each thing is, an audio rack.
Each one of these, so that's going to be its official or part number.
Yeah, well, yeah, the unit number.
So do you want to kind of go over a data tag and you know?
So this is the actual unit, and then this is what the unit goes in typically, or if it doesn't go in anything specific, then usually certain letters are left out. This says what that unit is. This tells you what it's a unit of, and then this case is made for the Navy and by Teletype Corporation. So this is the tag off of that thing we're stripping for the parts. So there's a whole lettering system that's used for military nomenclature. So that's the letter system to speed. So AM is amplifier, C is control, power supplies PP, the dummy load is DA for dummy antenna, and etc. The GR means ground radio. So this is a ground radio type of system. The original tags on top of the racks have that nomenclature.
And even the MWO pulse modulator has a data tag, which is MD, which is modulator.
Yeah,
and then UA is invisible rays.
U is utility. In other words, it can be used anywhere. It's not really shipboard or aircraft, or it's wherever you use it. And the A was the original designation for invisible rays like infrared or night vision things or what have you. So like in this case, F means fixed, which means it's going to be inside a building, which is air conditioned and all that type of stuff. And G means telegraph, and C means transceiver, and 5 is where it went along the line, and CV means converter, and then the number is whatever. And this is the actual set that the thing comes out of, is an ANFGC5. So it's a fixed installation telegraphic transceiving apparatus. That's what FGC means. Now, if it was SGC, it would be shipboard. If it was BCG, it would be submarine. If it was G, like in this case, GGC, it would be ground. If it's V, it would be vehicular. And if it was P, it would be portable. So that's all. Each letter has its own.
Right.
Each row has its own letters.
So I guess we can snap those 2 units in here, screw them in, take a few pictures,
yeah.
and call it a wrap.
Yeah. That's going to be some grunting.
Until the next episode.
I'll let you and Jeff do it. I'm beyond that now. Where'd Jeff go?
He'll be right back.
Well, the screws should be there.
Okay.
From the back. Someone's got all this lift in the back. I think in this case it's going to take like 2 people lifting in the back to get that aligned. Maybe not. You got it?
And these are not the right handles. We got to get bigger ones. I got the video.
Okay. Rolling. Adjust this in the back so you can keep those holes lined up. Got to kind of pull in and lift. Those screws are one size too big for the rack panels. The maximum we use on rack panels is number 12, not quarter.
Yeah, that's why they made them.
Well, this had some kind of special piece of equipment in it that went with the rack. It's not totally a standard. Judging by the color of the gray, I would say that it's Western Electric. It was Bell Telephone. Bell Telephone Labs designed it, because that's Western Electric gray. Every company's got its own colored gray.
I'll just show real quick, like we try to consider for everything, even these support bars, to make them, not just flush with this, but we want everything flush so that when we bring it in, it actually sits on there, and this is part of the support structure for the unit above it, in addition to these support bars. So we'll bring the 1,000-pound transmitter in here and plug it in.
Too bad you don't have a scale.
Not for that weight.
Well, Sean, I should go ask Sean if he's got a scale over there.
Yeah.
Let me go ask him real quick.
Okay.
238.
£238, and it was 190 before.
Yeah.
No, 180. No, 190. So it's only 48 pounds.
Huh.
48 pounds.
It's only half the weight of the Collins.
But it's really back heavy. Yeah, let me keep this.
You might have to take those screws out. I don't think you can slide it in anymore.
Yeah, just setting it there. Okay. Want to grab a couple of those screws, Eric, so I can put those other two in?
Where'd they all go?
I don't know.
I used them up for the bottom one.
Oh, okay, well, you get two more.
Actually, that misses this whole sidewall altogether. Could yeah, it misses this whole thing altogether.
What's that?
Doesn't even touch the side rails.
Yeah, because it's inside.
Unless we want something under
Well,
here.
there
to
probably
rest
should be
on
some
it.
kind of bar that
Yeah.
goes across the back. Well, no, if it doesn't, well, I don't know. It seems to be okay as is, but it probably wouldn't hurt to have some kind of
Yeah.
alignment piece. Oops.
Maybe we could have a thin bar bolted right in to for that to rest on or something.
Well, I'd almost rather the bar be on this, not tamper with these.
This will be the easiest unit to put together. It's two tubes that go here. What kind? Oh, those iMac tubes
Well,
you
we can
said.
plug one in.
That screwdriver?
Right there. It's a lot of stuff to make from scratch and make it look good. Looks real damn good. Pretty amazing. We gotta put a window on that. A little plastic window here. That way you can see the tubes through it.
The other one in.
So what's missing? What are the other two?
Well, hold on, let me take care of this. Both tubes in there. So that's what those will look like. Those things can crank some power. Particularly operated in the high voltage mode, you can get a lot more power out of them.
So this is 1500 watts.
It should be 3,000 watts CW and 1,500 watts AM.
Can you explain the difference?
AM is amplitude modulation.
Mhm.
So, because the modulator power is going out as well as the RF power, the RF part of the transmitter is usually cut in half.
What does CW
So the
stand?
modulator is going to be, the modulator put in 750 watts. So in the AM mode, if it's the peak envelope power will be 4,500 watts.
And define CW mode?
That's when it's just either full on or full off. The CW mode, the plate voltage goes up from 2,400 to 4,800, so the tubes can put out substantially larger quantities of power. So I'm using the circuit designs in here are such that I can get more power out of these tubes than you normally get. So the tubes are rated for dissipating 500 watts as a pair, or 250 each. That's why they're called IMAC 250s. So if I have 500 watts of dissipation, and I figure that my maximum efficiency is 90%, that's well over 3,000 watts. So it's usually safe to consider them 3,000 watts.
Until the next episode.